Get to hit the record button. So now that we know how to find the mean, we need to know how to find the accompanying standard deviation. So I'm going to show you two ways. I'm going to show you how to do it by hand, which is fine for short lists of data, short lists of probability models. If you have a lot of numbers or a lot of outcomes, though, you're going to want to be able to use the calculator. So I'm going to show you how to do it on the calculator so that it does all the number crunching for you. But of course, I'm going to take you through the long, torturous way first because that's just how I do things. So we're going to go back to the problem that we ended with yesterday about the air conditioning repair and just pick up with the formula. So we found out yesterday in that problem where we could pay $60 to recharge the air conditioner or $200 to recharge that doesn't work and then replace it. And we computed a probability model and then computed the expected value or the mean. And we got $95. So if you were here, that should sound familiar. So on average, the mechanic can expect to make an average of $95 in the long run per repair. And so you see both notations here. E of x is what we were using yesterday. Expected value is sort of a probability term, but it is an average, so the mu of x is an alternate notation for that. In order to find the standard deviation, you have to start with the mean. So the mean has to be computed first because the standard deviation is sort of a measure, sort of a pseudo measure of the average distance that all your possible outcomes are from the mean. You're measuring distances away from the mean. So you have to start with the mean. And then we have to first see how far each of our possible outcomes is from the mean. So those are called deviations. So we have a little table here. You'll notice that there's an extra row here that shouldn't be there, and I don't know why, so we'll just pretend it's not there. We know that we had a recharge cost of $60 with a 75% probability, a replace charge of $200 with a 25% probability. So that's yesterday's numbers. And we're going to add to that two more columns. So you could just add to your table if you're going to do it by hand. Instead of building a whole new one. I would never build a whole new one. I would just add two. So we're going to compute the deviations of each x value from the mean. So x minus mu, observed minus expected. So if we have a cost of $60 and we subtract the mean of 95, that's negative 35, right? Yes, Mr. Rice, it is. Okay. And then we take, for the second possible outcome, $200 cost, and subtract the mean of 95, that's 105, right? Okay, so that means that the recharge price is $35 less than average, and the replace cost is $105 more than average. So how those numbers differ from the average is your deviation. And then we want to square them to make them positive. So it's the same thing we did with data back in like chapter 3. So we square it to make everything go positive. So we take negative 35 squared and 105 squared. Okay, so you're going to have to grab a calculator. You guys have calculators. Do some calculations for me. What is 35 squared? 1,225. Sounds good. What is 105 squared?
11,025.
11,025. Does that sound okay? All right, so of course squaring gets rid of negatives, but it also sort of over amplifies things that are far away from the mean and gives them a little more meaning, a little more oomph. And then we need to calculate the expected value or the average of those squared deviations. And we call that the variance. Fill in the blank there. So we're going to actually average with weights those distances from the mean, those displacements. All right, so I need, well, let's call that variance. So how about VAR of x? So we'll use VAR for an abbreviation for variance. There is actually a Greek letter for that. We'll come back to it. We'll just do a little bit at a time. I need the expected value of those squared deviations, which means I'm going to take the first squared deviation, 1225, and multiply it by the probability of that happening, which is the 75% back here to the left of it in the table, so 0.75. and then add to that, so we're doing a weighted average of those square deviations. So same process we did with the mean. Then we take the 11,025 and multiply that by its probability of 0.25. And if we add all that up, we get 3,675. So the variance is 3675. So that's a pretty large measure of spread. Now, let's talk about other notation while we're at it. Sigma, the lowercase Greek letter sigma, is for a standard deviation. And if you square a standard deviation, you have a variance. We've not seen those terms for several chapters. So this is old stuff that probably is really, really rusty and buried real, real deep in our heads if it ever got buried there to start with, which it should be, but it may not be. Sigma is standard deviation. If you square it, you get the variance. So technically this is sigma squared of x. And I'll put that x in as a subscript. Because it is a squared unit measurement, we squared our dollars back here before we ever stuck them in the formula. And I need my answer not in square dollars. I need my answer to be in dollars. So how do I make a square go away? You take a square root. So if I want the standard deviation, which is what I really am after, that's sigma of x without the square. That means I have to, and that's the SD of x, which is another notation, SD for standard deviation. You don't have to use both. I'm throwing them both in the notes so that you get used to seeing them, but you can pick one and just use one. I'm just showing you both. Technically, that is the square root of the variance of x, which is the square root of that 3675. And you'll need a calculator for that. So give me 60.62. It is money, so nearest hundredth makes the most sense. So we have an average repair bill of $95 with a standard deviation of $60.62. It's a fairly large spread, because there's a big difference between a $60 charge and a $200 charge. So you would expect a very large spread, average distance from the mean. And that's what that really is. And eventually, we might be able to use the standard deviation and the mean to throw in a normal model and do some additional work with it, which is where we're eventually heading later on when we do inference. For now, it's really just about being able to use the formula. Now, you do have a formula, and I'm not going to have you switch back to the first page of notes. Let me just pull it up here. The formula that I gave you yesterday, and I said just ignore it for now because we don't want to look at it yet. This is from an earlier page of your notes, an earlier slide. The standard deviation formula is in the blue book. And first you have to calculate the variance. So you actually do variance and then take the square root to get the standard deviation. So what really is in the book is the variance formula. So we're going to take each of our little x values, subtract the mean, which is what we did right here in the table. Then we'll square them, which is what we did in this part of the table. Then we multiply them by their probabilities, which is what we did here. And then the sigma says we're going to sum those, which was when we added them here. So we actually applied this formula, but we did it in like sort of baby steps. And then we take the square root of the variance to get the standard deviation. And then your alternate notations are all there as well. So that's already in your notes. It's just back on a previous slide, so that when you're trying to absorb it all and going back and studying, and trust me, the multiple notations is tricky. It's hard to get that all in your head. You're going to need to study this some, and if you're too stubborn to study it, you're going to have trouble with it. So just trust me on this one. You need to practice the notation, especially when there's 3 forms of everything. Okay, so that's the first shot at a standard deviation. Let's do another one, because one example is just not enough. So move on to the next slide. And you'll recognize this table as the additional examples that we did yesterday, that very last slide in the day 1 notes. So we did the mean computations, the expected value computations for these two variables, x and y, yesterday. So let me just pull back the information from the first day. For x, we ended up with an expected value of 1.2, and that's back in your notes. You could look back at it if you need to. And when we did the expected value of y, we found out that the expected value of y was 280. So we've already worked that out. We're not going to go back and reinvent the wheel. It's already been done. But we'll need to reference that to get the standard deviations done for these. So now we need to calculate the standard deviation to go with each of those random variables. So what would be really nice is if I didn't have to add a bunch of stuff to the table. Would anybody like to do it all in one step? Like really pretty, all at one time? That's what I really want to do, is to apply that formula all in one step if I can. So I might even just pull it out here so I can look at it. So I have a mean of 1.2 for the x, and I want to calculate the standard deviation of x. So I'm going to do the variance first. So for problem number 1, I'm going to do variance of x equals, now I'm going to sum some things, add up some things. I'm going to take each x value, so open parentheses, take an x value. Well, let's see. In the first row, the first x value was 0. So that's this number right here. 0 minus mu of x is the mean. Same thing as the expected value. That's the 1.2. So minus 1.2 and square it. And then multiply it by the probability that accompanies it, which is right under it. That's that 0.2. Alright, so I'm embedding it all in this one fell swoop instead of having to add a bunch of stuff to my table. So do the subtraction, square it, then multiply all in the same step. Alright, I'm going to add to that any additional outcomes. So plus, take your second x value, that's a 1, subtract the mean of 1.2, square it, multiply by the corresponding probability of 0.4, and then continue to do that for each of the outcomes. So add the next one. We have an x value of 2. Subtract the mean of 1.2. Square it. Multiply by 0.4. And the rest of that is calculator work. So here's what I'm going to trust. I'm going to trust that you can type that in the calculator just the way it looks. Parentheses, squares, minuses, multiplication symbols. And I'm going to go ahead and just give you that number. And we won't waste time on actually doing computations. We end up with a 0.56 after we do that computation. And it is time consuming. On the AP exam, if something like this pops up in a free response question, you have to show the setup. You can take a shortcut to compute it, which I will show you at the end, but you have to show the setup. In a multiple choice, they don't care how you do it. You can put it in a table, you can put it in a spreadsheet, and let the calculator do it. All right, let's do the second one just for practice. Oh, no, we're not finished. That's the variance. I need standard deviation. Standard deviation of x is the square root of the 0.56. So we've got one more step to do. So we're going to have to take the square root of it, and square root of 0.56 is about 0.748. So the standard deviation for x is 0.748. Okay. It's not a real hard formula. It's just got a lot of pieces to keep up with. You don't have to memorize it. It is in the blue book. You just have to be able to apply it. Now let's do the second one for extra practice. So number 2, start with the variance of x. Take each x value and subtract the mean. Bless you. So we have parentheses, 100 is the first x value, subtract the mean of 280, square it, multiply by the corresponding probability of 0.1, plus, now here's a nice little rule of thumb for if you have a whole bunch of terms. If you have more than 3, it is acceptable to show 2, use ellipses, and then show the last one. So if you had 10, you could show 2, show ellipses, show the last one. So if you could actually leave out the third one here and still be okay. Up to you. It may or may not be worth it. Then we have a 200 minus the mean of 280. Square it. Multiply by 0.2, its corresponding probability. And because I have limited space, I'm going to do the ellipsis thing. So I'm going to do plus, dot, 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 plus. I'm going to skip the third one. I know it's included, and then I'm going to show how it ends. So you establish a pattern, and then you show how the pattern ends, and that's considered complete work. So the last term is 400 minus the mean of 280, square it, multiply by 0.2. A lot of stuff to calculate. This is where having a trick in the calculator comes in handy, which is the last thing I'm going to show you. But let's finish this one first. That actually tallies up to 7,600. Nice, pretty round number. And then we'll finish it by taking the square root. So standard deviation of x is the square root of 7,600, which is approximately 87.18. So that one has a fairly large spread, which makes sense because you're looking at numbers like 100 to 400. Okay, so can you use a formula? That's it. Can you use a formula? Yes, you can. Okay, you can do this. Let me peek at what's on this last slide before the homework. Let the handheld do the number crunching. So how do we let the handheld do the number crunching? So grab your calculators. And because I'm videoing this, I'm actually just going to stick my handheld under here and hope that the light will work with me. And we'll take some notes out here to the side just so that we can remember the process. So maybe I'll start with a new document. So I'm going to go home, do a new document. Unless there's anything you want to save, don't save it. And let's add a list and spreadsheet. So I'm going to put a table in. That's a spreadsheet. So there we go. So we're going to, in the first row, put in our x values. So I don't really know what the context is. So do you want to do the one with the, let's go back and do the one with the air conditioner because it actually has a context. So let's do cost, and it's short. I like short. So I'm going to put my costs in the first column, and you can abbreviate that. You can just call it A if you want to. And then in the second column, I want my probabilities. And you'll have to be careful because some abbreviations are reserved. Prob is not. So you can abbreviate. You can just call it B if you want. And we're gonna basically put our table in. So our costs were $60 and $200, and our probabilities were 0.75 and 0.25. Now let me make some notes as I go. So step one is to input x's and probabilities in a spreadsheet. I'm going to go ahead and write down the instructions just to get that over with, and then we'll walk through them. Then we will run some one variable statistics, because we just have one variable. It's the cost. The other row is probabilities. That's not a variable. Those are just weights. X is the variable. In this case, the cost. And P of X is going to be what we call the frequency. That'll make more sense when we run through it on the calculator. Just jot it down for now. How frequently it happens is technically a probability. Alright, so let's go ahead and run through that. As soon as you get that copied down, we'll give you a few more seconds to copy, and then if you're ready to go, we'll roll. Anybody need more time? Okay, so we go to menu, and statistics is number 4, and stat calculations number 1, and one variable statistics is your first option. Everything else is for like linear regression stuff. And it asks how many lists. This is how many variables. We only have one variable. Okay, so one list, one variable. Don't change that. The X list is your cost. So I'm just going to drop down my variable name, or I could type it in and input cost there, or whatever you called it. And then the frequency list is your probabilities. How frequently each of those costs occur is what it's asking you for. So that is your probability list, whatever you called it. And then press OK. That's all you need is to tell it those first two things. And then you get in that side column, you'll notice X bar is 95. Technically that's the mean. So the mean mu of X is the X bar on your calculator. And then if you scroll down, notice S of X is not defined. That's actually a standard deviation of a sample. We need the sigma here, the actual model. And the standard deviation, sigma of X, is it's the sigma of X. It is labeled correctly. X bar is labeled kind of, same as it would be if you were doing a sample, but 60.62. So the calculator will do all the computation for you if you just put it in a spreadsheet, which is really, really handy if you have a lot of X values and a lot of probabilities. But on a free response, you still have to show how to set it up. But you can let the calculator finish all the number crunching for you. All right, questions, comments, teardrops? That's it. So next slide has your homework for the day, and you got plenty of time to work on it.